Your goal today is to find the inverse of a given function and to also find the domain and range of that function and its inverse, with the added restriction that x cannot be less than 1, but it can be equal to or greater than 1. So your first step in finding out the answer to this problem is to change f of x to y, so that f of x changes to a y. And you do this so it's easier to look at and deal with, so in essence you don't have to deal with f of x. That to that. Your second step is to solve for x, and you need to, excuse me, you'll do that because you need to know what x equals to find the inverse. So y is equal to x minus 1 squared. To solve for x, I'll first need to take the square root of both sides, and you're left with plus or minus the square root of y, for now at least, is equal to x minus 1. The next step is to isolate the x by adding 1 to both sides, and you're left with plus or minus y plus 1 is equal to x. But remember, because of the added restriction that was included up here at the top, x can only be greater than or equal to 1, so in this case your answers can only be positive, so you're left with y plus 1 is equal to x. Your third step in this problem is to switch your x and y so that you can find your domain and range. So this y will come over here where the x is, and the x comes over here to where the y currently is. So you're left with this over here. And just remember that now that you've switched this around and you found the inverse, that y is equal to f inverse of x. Your last step is to determine the domain and range of f and its inverse. So your domain was actually already given to you at the beginning of the problem, because if you were to have, for example, I know it doesn't say in the problem, in the start of the problem, that you need to graph this, but in order to get a good visual look at what this would normally be, if you have a regular parabola right over here, it will look like this shape over here. But the problem we were given was f of x is equal to x minus 1 squared. So the only thing that's going to change right here is that this is being transformed, shifted to the right 1, so that the vertex is actually not at the origin but at 1, 0. But in order to have an inverse, a restriction was added to this problem so that x can only be greater than or equal to the point 1 right over here, so any point to the left of that right here can't be included. So what that does is that this right over here is all you need to consider when you're finding the inverse, and not this part over here, because if you did include this part right here, sure, a parabola can pass the vertical line test, but it won't pass the horizontal line test, and therefore it wouldn't be a one-to-one function. And in order to find an inverse, you need to have a one-to-one function. So, with the added restriction, you've actually already been told what the domain was, and that it's any value equal to or greater than 1. So, when written in interval notation, you write it like so. Here, let's try to hold this down so it comes in a little bit nicer. Positive 1 to infinity. Wow, that looks terrible. All you need to know is that that's an infinity sign. So when you switch the x and y values like you did up here, what that's going to do is that in the inverse, the domain of the regular function is going to be the range of the inverse function. So once you find that, you can already find this one over here, your range. a second. That looks even worse than the first one. So, all that's left to do is find the range of the regular function and the domain of the inverse, which will be the same thing, just like how these ones were the same thing. So, to find the range of the original function, what you'll need to do is take a look at what you've already been given right here. Now, in a parabola, just as I showed you before, no values are going to be underneath the x-axis over here, meaning that for your range, the values are going to be 0 or higher. So, to denote that in interval notation, you can include the 0 and go towards infinity, but no values are going to be underneath that x-axis. And so when you take the inverse function, your domain is going to be the same thing as the range of your regular function. That's supposed to be a 0. And that's to infinity with an open parentheses right there. And so, we found the inverse function, determined the domain and range of both the regular function and the inverse.